Hello everyone, welcome back to my YouTube channel. Today I will be teaching everyone how to configure a simple network using OSPF. So let's get started with the actual design of the network. So let's start off with some PT-empty routers. Okay, we'll just have 4. This is going to be a very simple network, so nothing complex. Just try to keep it short and simple. Okay, great. We have 4 routers. Okay, so now let's go into the first router we place, power it off. Then we add some modules to it. And then power it on, remember. Okay, and then let's power it off. Power it on, power off, power back on, power off, power back on. Great. Okay, so now what we're going to do is we have to connect all these routers together. So as we learned in our previous video, if is the same device, so router to router, we're going to use a copper crossover cable. So I'll do cable Ethernet 0 here. Okay, and just to make it a bit easier, I'm going to go into my preferences and I'm going to click this always short port labels in logical workspace. So this lets me see what interface interface the router is connected to, right? Okay, connect these two together, connect this, and then let's connect this. Great. Okay, so now we'll create a local area network. We'll just have a PC. We'll just have one PC. Keep it simple. And then we can have a switch. Sure. Okay. We just use an auto connection. Doesn't really matter. There we go. Remember, this is straight through cables, so it's this straight through. Okay. So let me zoom in more. That to see. Okay. So the first thing I would like to do is I would like to configure the host names of each router. So I would like to change this to R1, R2, R3, and we'll do R4. Okay, and let's change the host name in the actual configuration. Let's do enable, configure terminal, and then let's name this host name R1. Okay. Go into here, let's click no to the initial dialog box. En, T, host name, and this is R2. Great. Okay, next router. Click no to that. Host name R3. No, En, T, host name R4. Okay, great. So now we have our host names for each router. Now we have to enable each interface and assign each interface an IP address. So first, we'll just create a point-to-point connection. We'll just make this, we'll just use this IP address. Sure, we'll use this. And we'll use a /30 because this is a point-to-point connection. So we really only need 2 usable addresses. So /30 will be the appropriate subnet mask we should use, so we can conserve our unlimited IP address space. Okay, and then we'll just do okay, and then let's add some nodes. So we'll make this .1, do this .2, .1 here, 2, 1, 2, Okay, great. Oh, I think my note disappeared there. No problem. Let's re-enter it. Okay. So we're just adding these so it's easier for us to remember what IP address we configure on each interface. So some notes for us. Great. Now I want everyone to go into router 1. Okay. Now let's start configuring these interfaces. So let's start with the G0/0. Okay, we'll do no shut because remember router interfaces are down by default. So we have to enable them. So okay, great, it's enabled. Now let's assign an IP address. So IP address, we'll do 15.3.0.1. Subnet mask 252. Great. Now let's go to G10. Yep, G10. An IP address 15.4.0.1 255.255.252, and then no shutdown. Okay, let's go to router 2. Okay, we'll go into G0/0, IP address 15.3.0.2. There we go, and then we do no shutdown. So here we can actually see the link lights turning green because this interface is now in the up state. So this connection is working. We'll also look at do show IP interface brief. As you can see here, G0/0 has this IP address assigned and is in the up state, which is great. Okay, and let's go to G1/0. We'll do no shut, IP address 15.5.0.1. Great. Okay, we'll go into router 4. No shutdown, IP address 15.5.0.2. Going to G0/0. Also do no shut. All right, we'll do router 3 now. Okay, let's do IP address 15.4.0.2. 255.252. Gigabit 1. Okay, then we will, oh sorry, I forgot to enable no shutdown on the previous interface. Okay, let's go back. The interface we were working on. Okay, it's 2 and no, oh sorry, I believe I added an extra 0, my mistake. There you go. And then no shutdown. Okay, great. Now we're just missing one more IP address here, and I'll just assign this network to 10.0, and then we'll just do a basic /24 network. And then I'll just assign the last usable IP address to this interface for this local area network. Okay. Great. Okay. So now we have done the basic configuration. Each interface has an IP address. Each interface is also in the on state. Now it's time to create some routes. Now we're going to be creating dynamic routes, and we're going to do this using a dynamic routing protocol called OSPF, Open Shortest Path First. And it uses an algorithm called the Shortest Path First algorithm, also known as Dijkstra's algorithm. And this is a way for OSPF to calculate the best possible route to get to a destination network. And it uses variables such as cost to determine the best route. So let's configure OSPF. So the first thing, there's a couple different ways to configure OSPF. Well, we will first go into OSPF configuration mode. So first we do router, OSPF, and then the process ID. Now the process ID is only locally significant. It doesn't have to match between the routers. It only matters for the router you're configuring. So it's locally significant. So I'll just use a process ID of 1. Okay. And then we'll use something called the network command. So we'll do network. And then we'll do 15.0.0.0. And then this is something called a wildcard mask, which is basically an inverted subnet mask. So whatever is 0 has to match. Whatever is 255 doesn't have to match. So here we're basically saying, basically the network command enables OSPF on these interfaces. So G0/0 will be enabled with OSPF, and G1/0 here will be enabled with OSPF as well. That's the purpose of the network command. And we're telling the router enable OSPF on any interface with the IP address starting with 15. If there's an exact match, these other 3, they don't matter. Okay, because I specified 255.255.255 in the wildcard mask. So if I were to enable this, sorry, one more thing I forgot, area. So we also have to specify an area, and for our case, I'll just say area 0. Okay, so that is enabled. So OSPF is now enabled on this interface and this interface. So we can actually confirm that by, let me just do end show IP OSPF interface. Okay, so as you can see, this command lets us see what interface has OSPF enabled on it. So this interface has OSPF, and so does this, right? So both these interfaces have OSPF. Now we haven't created any neighborship or adjacencies with our other routers because OSPF is not enabled with them. So let's do that. So let's configure router 2. So again, we'll do router OSPF. Now the process ID does not have to match between routers. So I can use process ID of 2. Does not matter. So I'll do 15.0.0.0. And I'll do 0.255.255. Sorry, again, I always forget. Area 0. So now let's go forward in time. As you can see, an OSPF adjacency has been established. These are loading to full. These are neighbor states for OSPF. I won't be going into detail about that. Maybe in a later video I will. But when it's in the full state, that means that we have neighborship between these two routers using OSPF, and they can finally exchange routing information between each other. So, great. So we have created an OSPF neighborship. So now let's enable OSPF on this router. So let's do exit. Okay, router OSPF 1. We'll do network 15. Okay, great. Now there's also another thing we can do. We can actually enable OSPF directly on an interface. So we don't have to do we don't have to make a process, or we don't have to go into OSPF configuration mode. We can actually just do this. So we could do IP. So we can do int /0 IP OSPF. Okay, and then we can do actually I believe it goes like this, area, and then we'll do 0. So this enables OSPF directly on an interface. So I can also do it for G1/0. So as you can see, we have an OSPF adjacency that just formed. It's now in the full state, and loading has been done, and they have exchanged the necessary LSAs and their DBD packets, and now they're maintaining full neighborship using hello packets. And this terminology I'll get into another video, because then this video is going to be too long. So we're going to also make this interface OSPF enabled. So we'll do IP OSPF 1 area 0. Okay, so one thing to remember, the area must match. If routers are in different areas, they will not form adjacencies together. Okay, so the area must match, but the process ID doesn't really matter. Okay, so we'll enable it. Okay, so great. Fast forward in time, and there we go. So OSPF is now enabled on all of these routers. So let's look at the routing table on one of these routers. So as you can see, we have two paths. Okay, we have a path to this network right here, and we have a path to this network right here for router 3. And as you can see, this here is administrator distance. This is the metric right here. This 2 is the metric, and then this is the next hop that we'll take to get to that destination network. So as you can see here, the way you can read this is to get to 15.3.0.0, I will take the route that is from router 1. That is the best next hop. And then router 1, to send it to, let's say we're trying to ping router 2, it's going to go into his routing table. And as you can see right here, it already has a connected route to 15.3.0.0, so it can send it out of G0/0 interface. And that's basically how OSPF works. So instead of manually creating static routes, we can use dynamic routing protocols like OSPF to automatically configure routes to destination networks. So I also want to configure a OSPF route to this network, and this will be advertised to all the routers in this network. So let's do that. So let's go to what we learned. So instead of doing the network command, we're going to enable OSPF directly on the interface. So we'll do IP, OSPF, process ID, area, and then 0. Now one thing I want to do is I want to go to router OSPF1, passive interface, G2/0. So the reason why I'm doing this is because OSPF enabled interfaces always send hello packets and are trying to establish a neighborship with the interfaces they're connected on. So instead of sending unnecessary traffic on this local area network where there isn't any routers, we can use the passive interface command to disable OSPF from sending hello packets from that interface. So let's enable that. Okay, now so it won't be sending any hello packets, but this route to this network will still be advertised. Okay, so let's give it a second. Okay, now let's see the routing table for this router. As you can see, we now have a path to this network. Okay, and we actually have two paths because they are of equal cost. So this, since we have two paths, now what we could do is we could perform ECMP load balancing. So we could load balance by using these two paths to our destination network. And the reason why we have two paths is because they are equal. The administrator distance is the same, and the metric, our cost to the destination network, is exactly the same. As you can see here, we're using gigabit Ethernet interfaces, right? It's exactly the same. So that's why it'll just load balance between the two paths. Okay, so then what we can also do is we can test network connectivity, see if everything's actually working. Can we actually reach this network? And can we reach other routers from PC0? So let's put in the default gateway. Okay, great. And then we'll put a IP address for PC0. Okay, so the mask is fine. Great. Okay, so what I'll do is I'll ping router 1. Go to command prompt, ping. Let's see. So we'll do 15. We'll ping router 1 G1/0 interface. So ping .1. And as you can see, we are getting a reply from router 1. And we can actually go into simulation mode and see this a little better. Okay, so we can see the ICMP echo request packet travel to router 1 G1/0 interface. There you go, it has received it. Now it's going to travel back. So as you can see, it needs a different path to get to the destination network. It could also use this path. They are the same. they're equally, they have equal cost. They're exactly the same. And there we go. There we have it. We have successfully configured OSPF on our network. And yeah, that's it for this video. Just a basic introduction to OSPF configuration. I will create a video whenever I get the time on what is OSPF and the theory behind OSPF and the neighbor states such as down, init, xstart, stuff like that, and explain OSPF in further detail. But for now, I hopefully someone has learned something from this video, and hopefully you can now configure OSPF in your networks so you don't have to always statically configure all your routes. And thank you for watching, and I hope to see everyone soon.